Good afternoon, everybody. My name is Giuseppe Lamantia. I'm in charge of all the floor departments. It goes purchasing, supply chain, and production, some for the raw material to the final part. So today, in this presentation, in fact, we are going to talk about our story, about Safran Blade, and how we developed the 4.0 on our factory. In fact, the aerospace industry is really demanding with precision, accuracy, traceability, and all of that. And so we will see after that in the presentation how we move with 4.0 with this kind of point. So here we are going to explore the 9 pillars. This is the architecture we developed to build the next generation forging factory. And after that, all the results, the lessons we learned about that, and the pitfalls to avoid. So, who is Safran Blade first? Safran Blade is a subsidiary of Safran Robuster. It's located in Huy. It's in the region of Luik. Our main industry focus is based on forging. As you can see on the part there, between the two rings, you have some blades. This is the part that we have to build. We start from the raw material to the final part, which is ready to be assembled on the engine. Our first goal was to be able to have a capacity to build 400,000 of these parts, with already a vision of 700,000 parts, which is already ongoing. So today we are ready, the capacity to do 400,000, and the next phase is already ongoing. The objective of Safran Blade is to straighten the fact of having this kind of parts, which historically were built all around the world. And we saw that different crises we see with COVID, that we needed to put this industry again to our place. What I wanted to share with you before to talk about technology and 4.0, it's the way of work. How do we work, in fact? And this is really something important because Safran Blade started from scratch, completely something new. It was established in 2022, in December, so it was less than 3 years ago. 3 years ago, we had something completely empty. We made the building, we bought some machines, we put them inside on the shop floor, and we started to industrialize our process. Today, and I'm happy to tell you that next week we are going to send our first part. And this is something really important, how to achieve, how to arrive there within the 3 years. First is that we know the submit. We know where to go, we know the objective. In our case, the objective was to be competitive, to be a state-of-the-art factory, and for the group Safran, it was to be the center of excellence for forging parts. For Safran, it was something new, this kind of production with very high pace, with small parts, with high cadence. It was something new. So we had to build something new. Of course, it was really helpful to have the help as a group, as a Safran, for different tools, methodology, and support. Something really important, and this is one of our value, we have to accept that we don't know everything. To be honest, when we decided to put this factory in Belgium, we needed to be competitive, and so we started to talk about digital, about 4.0 industry. To be honest, for us, we didn't know what it was, but we needed to prove, to sell that to the group, to be able to say, okay, we are going to be competitive. And so we had to learn and to define what is 4.0. And a way of work is to accept mistakes. This is something really important. In fact, sometimes it can take a lot of time to develop things, to say, okay, what are the risks, where we can go, and what if that, what if this happens? In our case, in our philosophy, sometimes it takes less time to do it than to think about that. And so this is why we have to plan the best route, but we don't have to waste time over planning. We move step by step. We have to launch quick to make efficient tests, and as soon as we have something efficient, we have to anchor it into the company and to develop the process around that. So the game changing is a 4.0. There is here something we would like to share. It's what we call reasoned automation. In our case, with this speed of production, we need a lot of robots, we need a lot of automation. But what we mean by reason? For example, on the top, on the right, you can see a heat map of the shop floor. It shows the quantity of production made automatically or made by hand. And we can see that around 1 million hours of productivity, more than 100 are made by man hours. This is all the shop floor. But the man hours are especially on the red area. Why we've got this kind of heat map is because we put the added value where we need it. For example, forging process, it's something where we need to be really, really accurate. We need to move the part with tenth of seconds, for example. And this is for the quality of the process, the quality of the part, something important. In this area, in the red area, we have to move some parts from a basket to another one, for example. In our case, as we started not a long time ago, we decided to move that and to keep for the future. So this is what we call reason automation. It's just to put automation and digital where we've got added value. We don't do automation just to say we do automation. And this is something really important. After all of that, we've got all our shop floor, we've got a lot of robotics, automatization, and stuff like that. The added value is for the quality of the part, for the quality of the process, for the pace of the production. And at the end, on one part, on each part, we've got around 5,000 data. This data will make, at the end, the ID of the part. If we see with our concurrent around the world, this is something they don't do at all. This kind of process is you launch big batches, and at the end, you check, this one is good, this one is not good. And they have a high rate of scrap. In our case, we want to measure, after almost each step, and almost 100% of the parts, to see if the quality of the process is good. And step after step, we put this data into the part, and we are able to make the ID of the part. What is also important, because we are able to control each part step by step, is to see the quality of the part. For example, if we see that something is not correct, we can remove the part and then do some reworks or scrap the part as soon as we can. And this, as one of our objectives in aerospace, is to work on decarbonization of all the supply chain. It's something really important. The fact of working on decarbonization in aerospace is not just the fact of the engine on the aircraft consume less, but it's all around the supply chain. And having a high rate of scrap is really not good for sustainability. So our challenge is to do precision forging, and we have 3 manufacturing process overhaul. The first one is called the hot loop, and it's with all the forging process. At the end, we have the cold loop, which is in charge of all machining, and in between, we've got special treatment. At the end, you can see we have to commit a 20-second takt time. At the end, every 20 seconds, a good part with the good quality, with the good traceability, needs to go out of the factory. The aeronautical domain is really, really demanding. We need really a lot of traceability. As I say to all of our collaborators, when I take the plane, I want to land, to take off, and to land really in good security. This is why we need to be, it's really, really demanding domain. To achieve that, we have to ensure the compliance with metrology and all different process validation, which are really hard in our domain. We have to react quickly. We can see that all around the world, the demand can change really quick. And so we have to be able to do something that we can adapt. We need to be agile. We have to be able to change our process, to change if there is a new demand as fast as we can. On top of that, I wanted to talk about the MES software that we decided to include. So to tell where we come from, 3 years ago, it was completely empty. There was nothing. And we knew that for this kind of production, we need a good conductor. This good conductor is the MES software. In our case, we started to check on the market what was available. Our problem, it was that we were not able at that time to write a specification. All the company who makes the kind of software came back to us, say, yeah, but what do you need? What kind of process do you have? And we didn't have at that time. The company didn't exist. This is why we decided to move on with kind of system with this MES software from scratch. We really started from zero. And that was, I think, today, the good decision that we took, because we were able to improve this process, to create this process at the same time as the company. As you will see a little bit later, in fact, it's not just subject by subject, but everything needs to be in one system and very accurate in this system. And we'll see just a little bit after that how we improve our process, because we need it to make this factory smart. Before that, we have never forged some parts. It was something completely new for us. And as we wanted to become good as fast as we could, we needed to make this factory smart. So we needed to collect a lot of data, and then to do some analysis with AI to see how different processes can have interaction between themselves. But we'll see a little bit later about that. Let me just show you what we do at our place.
Imagine tomorrow and make it possible. This is the goal of many of us. In the heart of Europe, Safran, Wallonia, and Belgium have taken a bold gamble, transforming a brownfield site into a forge of the future in just 2 years to produce aircraft engine fins. And we kept our commitments. Safran blades. Much more than just a factory, a model of modern production at the dawn of a new era, an Industry 4.0 that combines automation, massive data collection, and artificial intelligence. In its sector, Safran Blades does not follow the times. It is ahead of them. Thanks to advanced robotization and digitalization, our patented processes make it possible to produce aircraft engine blades on a large scale with unparalleled precision, contributing to the decarbonization of the sector. At the dawn of a new era, where innovation is shaping the future of aviation, 10,000 square meters of concentrated new industrial practices developed to measure. To achieve this, we have surrounded ourselves with the best partners in Wallonia and in Europe, a collective dynamic where everyone has exceeded their limits. Technical advances that make industrialization possible in Wallonia, transforming robotization into human added value that creates new jobs. sovereignty is at the heart of our strategy. The climate emergency and geopolitical tensions have made the world aware of its vulnerability. Aeronautics is at the heart of these issues and is experiencing a turning point in its history. All convinced that by sustainably changing the air industry, we are building the world of tomorrow towards the impossible and beyond.
So we decided to produce this video because after making presentation on slide, it's better to see what we do exactly. And I hope you have a better vision when we talked about Blade, how it looks. And as you saw in the video, the strategic context is really complicated. We saw with the COVID, with the different pandemic, with the different geopolitical situation, that in fact for our shareholders, which is Safran Aero Booster, the fact of to regain industrialization, to be able to make our own parts, to be able to have this know-how, is really important to ensure the future. And this is something really important. We need this sovereignty about manufacturing, and especially in Belgium. And what I would like to share with you is the fact that if we are here after less than 3 years, it shows that it's possible to have this kind of industry in Belgium. At the end, with what is complex in our case, we've got high pace, and we will have to move on with different kind of production, with make to stock, make to order. We need a lot of flexibility in our shop floor, and this is why we need real-time data. About all the data I gave you, we are able to adjust all our shop floor, to adjust all the production, thanks to the MES software, based on the variability that we have. We all know that in high-pace production, variability is something to kill. We have to kill this kind of variability because our goal at the end is to answer the request of the customer, which is to deliver some parts with the good quantity, at the good cost, and on the good timing. And all this data give us the opportunity to achieve this result. Now we are going to move on, and I think it's the most important, is that this is the title of the presentation, about the 9 pillars to agilize digitalization 4.0 process and trajectory. What you have to know about this kind of graphic, it's to see that everything needs to be together. Of course, we need to put it on a slide. We need to explain. So we are going to explain one by one each step, but they are all in the same system. At the end, it's an ecosystem where everything works. Let's start with the first one. The first one is about instrumentation, about on different machine. So what is important here is when we started to make specification on the machine, for example, it was to put this kind of request already in the specification. To be honest, it was really something complex because for some manufacturer of machine, they just looked at us and said, but why? Why you want to communicate the state of the machine? Why you would like this kind of data? And sometimes for some machines which are kind of standards, it was really hard for them. And so this is why we need to push. In the case of integration, like us, this is easy because we can start from the beginning. The second step, you can see, is about communication and network. At the end, if we don't have communication or a good system to be able to have this motorway of data all around with new technology of Wi-Fi, with optic fiber, it's impossible to collect all the data. As I said previously, we've got 5,000 data on each part. Our factory puts on this network 100,000 data per second. And so if we don't have the good network, it won't work. The third one, you can see in the middle, it's something really important. This is the data room. In our case, we decided to use a UNS. UNS, it stands for Unifying Namespace. So this is all the servers and data that will take, it's called the data lake, and all the data, wherever they come from, will go in there. And this is how, after that, we can have the communication between all different devices and all different machines. On the number 4, it's what we call Safran link. It's about cybersecurity for Safran. We need, of course, to be compliant with this kind of security. Then the number 5, and this is the main point of our MES system. The MES will collect the data from the machine, and thanks to an APS, Advanced Planning and Scheduling, with as well AI on it to be able to analyze what's going on the shop floor, we'll be able to change the production in real time. And this is with this kind of pace. For example, we've got a machine with a tool that is broken now. It will be able to remove the production to another one. Or it will just say, OK, we stop the machine, and then we make a request to maintenance to come and work on it because the machine is blocked. And so the MES software is really able to do this kind of stuff, and of course, to ensure traceability. What I didn't say before about our 700,000 parts a year is that each part has got a unique number. And this is kind of new in this kind of production. It means on each process, we're able to scan the part and to see if first it's the good one and what kind of recipe the machine will use. And this is for us what is the 4.0. For example, in the process number 2, we've got a measurement. Based on that, the process number 8 will say, OK, now you've got this one. Pay attention that this happened, or this is the thickness of the part. You have to adjust your program or your recipe to be able to make a good part at the end. And this is really the added value we have to be sure you have really a good quality of the part at the end. Then the number 7, it's we see with robotic and automatization. Of course, we see that it's important. In our case, it's really because we have high demanding processes, and this is why we need to add robotic to be sure that we are really accurate and we do all the time the same things. You've got a small something written on the top. It's called IOC. It's something that we developed. As I said, we wanted to control each process one by one. And when we started to talk with manufacturer of the machine, we started to tell them, here we need control of thickness. Here we need to take a picture. Here we need to do that. And each of them had got their own standards. So they say, OK, we are going to use this robot. We are going to use this kind of technology. And at the end, it would have been a complete mess if we would have completely different structure and different brands on our shop floor. This is why we started to put out all this control out of each cells. And I don't know if you remember on the video, but there was front of a cell, a gray box. And this box was developed as a standard, like a car, with different options. So whatever the process, we can put this gray box in front of the cell and take the option of measurement, of photography, of engraving, or whatever. And this is what was really useful for us to be able to commit the takt time we needed. As you can see, it's written one IOC represents between 5 and 6 full-time employees. The next one, the number 8, it's about everything that is on the shop floor. We have, of course, different workers. We have different tools. And this is where we are going to add IoT and all of that to be able to measure and to see that if everything is doing well. And this is really important as well. And what I did already at the beginning, it's the fact of measuring energy. We use a lot of electricity with our machines. And this is why we decided to measure the energy of each one to be able to increase as well sustainability. And at the end, we noticed that after that, we were able to detect some defects thanks to the energy that we measure. And this is something else that we added with AI, and we'll see some use case that a little bit later that we add. And of course, after all of that, we can see we've got people behind that. What is important about all the people? Of course, we need data engineer, data analyst, and so on. But it's the fact that all this kind of project about digitalization, in fact, is not led by IT teams, but by the shop floor itself. At the beginning, we said, okay, we have to do 4.0, but what do we need? And the need and the customers of that is on the shop floor. So it's the different engineers, it's the different workers on the shop floor. For example, for the forging process, engineers say, okay, I don't know what forging is. I'm new on that. Can you please give me a tool to make this kind of stuff? Then we need traceability. We go to see IT, I need traceability. What do you mean by traceability? Do you need to follow the batch, to follow the path? And we go to see the IT to develop some tools all together. And this is really important to see that all of that at the end is a complete ecosystem working all together. If we go step by step, one-to-one, it won't work. At the end, something won't follow what we decided to do at the beginning, and it will be a complete mess. I see that the time is really moving. I want to show you this about AI that we are using. At the end, is to ensure the quality, again, the quality, the cost, our traceability in our production. I'm going to show you again a video that explains what we did with all our structure, which is made by AI.
The year is 2025. Data has become the lifeblood of all organizations. But how does this energy circulate between machines, humans, and artificial intelligence? Imagine a vast ocean of raw, unstructured data. It's not a database, it's a data lake, a repository of all the information generated by our Factory 4.0, sensors, logs, videos, texts, IoT, machine and manufacturing data. But to harness this ocean, we need to transform raw water into decision-making fuel. This is where the ETL process comes in. Extract, we capture the data. Transform, we purify and structure it. Load, we send it to a database ready for querying. But in the era of distributed systems and Industry 4.0, a problem persists. How do all these systems communicate with each other in real time? This is where the universal namespace comes in. The UNS is a real-time integration architecture, often based on MQTT. It creates a universal folder structure so that every machine, every sensor, every service knows where to publish and read data. ETL structures information. The data lake stores and preserves it. The UNS connects it and brings it to life in real time. Together, they enable hyper-automation of production, predictive maintenance, and even strategic decisions. When data becomes reliable, structured, and connected, intelligence can finally emerge. Industrial AI, the engine of optimization and prediction. Thanks to AI, we model our factory in real time. We dynamically adjust the use of resources, materials, energy, and machinery. We reallocate production resources based on demand, anticipated breakdowns, or logistical issues. We automatically detect performance deviations, bottlenecks, and invisible waste. And even further, AI no longer just predicts breakdowns. It recommends what to do, when, and how to intervene. This is prescriptive maintenance. In Industry 4.0, data is no longer a passive resource. It is a living substance transformed by ETL, structured by UNS, stored in the data lake, and revealed by AI. It is human-machine collective intelligence. The factory becomes predictive. Maintenance becomes prescriptive. Processes become autonomous. Our factory no longer executes its operations. It orchestrates them.
And so, as you said, this is what brings us already to Industry 5.0. To be honest, I just understood what is 4.0, and we're already thinking about 5.0. At the end, it's human-centric new industry with adding value on sustainability. And just to conclude, to finish about that, we see that digital transformation is really important for resilience, competitiveness, and sustainability. This UNS, which is in the center of everything, is the most important, and this is where everything is able to communicate with everything. And this is the main structure that we need today. And of course, we have to continue to move on to have evolution for different environment and strategic autonomy. Thank you for listening. I hope it was clear. And if you have any question, you can still ask me after that. Thank you.